In this video, we will demonstrate the end-to-end configuration for sending data over MQTT using the TagoTiP protocol, resulting in real-time data visualization on a TagoIO dashboard. TagoTiP is how you connect devices to TagoIO using MQTT, included in every plan. To keep it viable as a free shared broker, a few MQTT features are not supported: retained messages, last will, persistent sessions, and offline message queuing. The topic structure is also fixed. You publish to $tip /serial number /push and subscribe to $tip /serial number /ACK or ACK. If your use case depends on those features, a dedicated broker is the better fit. We'll start the setup by generating the necessary credentials. In your TagoIO profile, navigate to the authorization section and create a new authorization. Ensure the token format is set to TagoTiP MQTT. Once created, copy the username and password. Unlike TCP or UDP, MQTT splits the token hash 16-character hex string in half. The first 8 characters become your MQTT username, and the last 8 characters become your MQTT password. The server concatenates them back together to authenticate your profile. With the username and password secured, the next step is to create a device. Go to the Devices section and click New Device. Search for the TagoTiP MQTT connector. During the setup, enter a unique serial number. For this tutorial, we will be using 12341234. Unlike TCP, where the serial lives inside the payload, with MQTT, the serial is embedded directly in the topic path, so keep it short and URL safe. Now that the device is registered, we need to identify the correct regional endpoint. You must target the endpoint depending on the server you created your account on. For servers located in the US, use mqtt.tip.us-e1.tago.io. And for servers in Europe, use the region EU-W1. The destination port for plain text MQTT is 1883, and for MQTT-S over TLS, which is recommended for production, use port 8883. If you need to stay on 1883 but still want application layer encryption, TagoIO supports $tip S/topic prefix, which we'll cover in a separate video. Before sending the payload, let's enable the live inspector to watch the data arrive in real time. Navigate to your TagoIO device and open the Live Inspector tab. Click Inspect. With this running, we can verify that the TagoIO server receives and parses our message the moment MQTTX publishes it. So now we're ready to configure MQTTX. There's 3 things to keep in mind for MQTT-TIP. Every device must subscribe to its ACK topic to receive responses and server commands. The payload on the wire is just the TagoTiP body, no action keyword, no serial, no token, because all of that is already encoded in the connection and in the topic. And if the device needs to read latest stored variables or values, it does that by publishing a pull request to $tip /the serial number /pull with the variable names, and the response comes back on the ACK topic. So let's open MQTTX and create a new connection. Set the host to mqtt.tip.yourregion.tago.io, port 1883 for this demo, and add your username and password. Lastly, hit connect. Once connected, first add a subscription to $tip /the serial number /ACK. This is how we'll see the server's response and any commands pushed back to the device. Now we'll publish a message. Set the topic to $tip /12341234/push, and the payload to bracket temperature 2 dots equals 22.5 #C closing brackets. I'll hit send now. As you can see, MQTT received a confirmation on the ACK topic, and the live inspector shows the parse temperature variable, meaning the data has been correctly stored in your bucket. Before we visualize the data, let's confirm we can read it back. In MQTTX, create a new publish message with the topic $tip /12341234/pull and the payload. In this case, the payload will be the name of the variable itself, so temperature, and hit send. As you can see, the ACK topic returns, giving us the last value and the timestamp. This is how the device can query its own state on reconnection, useful for devices that wake up from sleep and need to know the last reading before deciding what to do next. Finally, we'll map this verified data to a visual display. Create a dashboard and add a widget. Select the device and the variable name defined in your payload, in this case temperature. The widget will now update in real time as MQTT messages are received. This completes the full integration from MQTTX to the dashboard. You've now implemented a complete TagoTiP over MQTT data flow. From here, analysis can run logic on incoming data, actions can trigger alerts, and dashboards can share your insights with users.